Alright, so in this question, we are determining quantities in an equation for a transverse wave. We're given the general equation, y equals y maximum, which is the amplitude, sine kx plus or minus omega t plus phi. Like I said, this equation can also be written as sine omega t plus or minus kx plus phi, of course, if we have a phase difference. We know if we have a phase difference um, if the wave does not pass through the origin. So we are given these graphs for the displacement as a function of x and as a function of time. And we want to find the values of the quantities shown in the equation, including the correct choice of sign. So the first and most straightforward component or quantity that we can find is y maximum. It can be found from both graphs. From the maximum value of the vertical displacement y, we can see that the maximum value of the displacement y is right here. This is the maximum value of y that the wave can reach. So this is ym, and it's equal to 3 millimeters, knowing that the divisions here are given and the unit is given over here as well. So this is y maximum, and of course we prefer to write this in SI unit. The second variable that we can find is probably lambda from graph A. So as you can see, graph A shows y as a function of x, and we said that whenever we have x or displacement on the x-axis, then the distance between two troughs or crests will give us the wavelength lambda. So this graph will give us lambda. It's the distance between two peaks or two troughs, and we can see here that this distance is given by these divisions, which are basically 5 divisions. So 5 divisions, and we can check the scale. Since this is 4 millimeters, then this is 2 millimeters. So every division is 2 millimeters. This gives us 10 millimeters, which is 10 power minus 2 meters. So this is the value of the wavelength. From graph B, we can find the period t. So graph B, on the x-axis, we have the time. So we can tell that the distance between two peaks will give us the period t. So we can look at these two troughs here. This is the period t. The first trough starts from here. Second one is here. And we can see that these are 4 divisions. And if we look at the value for each division, if this is 10, then this is 5 milliseconds. So every division is 5 milliseconds. So this is 5 milliseconds per division, which is 20 milliseconds, which is 0.02 seconds. So we just found lambda and t, and this is important for us because from these we can deduce k and omega. We know that k is 2 pi over lambda, so we can now find the value of k. It will be 2 pi over 10 power minus 2, which is 200 pi. We can leave this in terms of pi. And we can also find omega, which is 2 pi over the period. So again, this is 2 pi over 0.02, which will give us 100 pi. So we just found k and omega. We found the amplitude, ym. We still need to find the phase and the sign. So as you can see here, we have plus or minus. We need to select the correct value of the sign. If we look at our wave, we see that it's traveling to the right. How do we tell this? So we check at t equals 0, so we check this graph, the value was -2, and then right afterwards, y increased in value. It became, let's say, -3, which means that we have a positive omega, and so the sign before omega t must be negative. So we check the value at t equals 0. It was -2 and then -3. So the absolute value of the displacement has increased, which means that the wave is moving to the right. It's moving in the positive x direction, which means that the sign is negative. So the sign is minus. Like we said, if the equation is ym sine kx plus omega t, this means that this is a wave traveling in negative x direction. And if the equation is ym sine kx minus omega t, then the wave is traveling in positive x direction. So since we have seen that this is traveling in the positive direction, then this means that the sign must be minus. So we finished the sign, and we still need to find phi. Now to find phi, what we have to do is to find a specific value for the vertical displacement at a specific position and time, and then substitute to find phi. So far we found the equation of our wave to be y equals 3 times 10 power minus 3 sine 200 pi x minus 100 pi t plus phi. And what we have to do is, like I said, take a special value of x and t, substitute in the equation with the corresponding phi, with the corresponding y to get phi. So let's take, for example, the position where y is, or the position where x and t are 0, or actually when x is 0, the value of y is -2, and the time is also 0. So we can substitute this and say this is -2 times 10 power minus 3 equal to 3 times 10 power minus 3 sine of 200 pi times 0 minus 100 pi times 0 plus phi. So this gives us that sine phi is -2 over 3. And then we can deduce phi. So here you should get a value of, actually I didn't calculate this value, so you can just do the calculations to get the exact value for phi.